Right, moving on. This period 2, chapter 6.5, where we look at inverse trig identities. Now, this is not quite the same as what we've done in the previous few lessons, which is about reciprocal. So let me just bring you back to the difference between reciprocal and inverse. So, right, so that's chapter 6.1. Reciprocal is 1 over sine x, 1 over, 1 over. Inverse is arc sine, arc cos, and arc tan. So it's the inverse. So if you, when you have to work on the x, you do the inverse. Okay, so this is what we do. Okay, the inverse. So that's arc sine, arc cos, and arc tan. That's what we look at today. Right. So what we're going to look at is, first of all, we're going to recall what's a mapping function. Where's the mapping function? So there are two types of mapping function. The first type is, okay, let's see if you remember chapter 2 knowledge, is about one-to-one, a one-to-one function, and the other one is a many-to-one. Now, only one of the above has an inverse function. Do you know which one? So only one of these two has an inverse. Do you know which one? The answer is one-to-one. Only one-to-one has an inverse. Well, why? Because the inverse of many to one is one to many. So you flip the many to one to many, that's the inverse. One to many, which is not a mapping function. Mapping function. Right? So what's the definition of mapping function again? The definition of mapping function is, okay, every input definition, every input has a distinct output. Distinct output. So for example, e.g., if we have y equals, let's say, root x. Now this is not a mapping function because if x equals 4, then y equal plus and minus 2. Now that's x equals 4 is an input. Y equals plus and minus 2 is an output. So the conclusion is f of x equals root x is not a mapping function. Okay, so if you want to know more, again, it's chapter 2.2. Right. Right, so what are the inverse functions in the graph then? We're going to learn the inverse function itself, and we're going to learn to draw the graph. So the function, first of all, is the inverse. We have talked about that before. The inverse of x is known as arc sine x. Inverse of cos x is known as arc cos x. Now, some people put a double C in there. That's fine. Arc cos x, that's, you know, it doesn't really matter. The inverse tan is called arc tan x. Right, so we're going to learn how to draw the graph. You've got space below to draw the graph of each of them. Right, so I'm going to show you. Now, you don't have to draw any of these graphs yet. I will teach you I will show you how to draw it. Okay, so on the screen, you should see a sine x graph. All right, so a sine x graph. This is in radians. That's why. Okay, so that's why I see x-axis is 2, 4. That's 3.14. That's pi. Okay, it's in radians. So now, okay, a sine graph that we're quite familiar with. And look at the arc sine x graph. Yeah, just like that. It's like you go, you watch the advertisement of McDonald's. You look at a Big Mac, you think it will be like as big like as a I don't know, like a car. But then when you see, it's like as small as a finger. Probably not a palm size, which is quite small. Anyway, so yes, arc sine x is only a small graph like this. Well, you may ask why? Because sine x is a one-to-many graph. Well, the sine x graph, because sine x graph, this is a many-to-one graph. So why is it many-to-one? Because if you look in here, so there are many values of x that give you the same value of y. So that's many x to one y, one y. So many-to-one. So as I said before, when you do the flip it, the inverse of many-to-one is a one-to-many, which is not a mapping function. That's why, to make it work, if we want to find an inverse, we must only limit part of the graph. So if we only take this part of the graph, I don't want to use blue, let me use pink. So if we only take this part of the graph, okay, actually pink is not good either, yellow. So if we only take this part of the graph, of the sine graph, okay, the yellow part is what we take, and then we flip it. Flip it means we reflect in the line of y equals x. So that's the line of y equals x. Where is that? -2. So that's the line of y equals x. Now you can see the yellow graph, which is the original sine x graph, reflected, it becomes the blue graph, which is the arcsine x graph. Therefore, in order to draw a inverse of the sine x graph, the arcsine, we're going to limit the value between, I think that's half pi, negative pi over 2 and pi over 2. All right. So similarly, we will see the graph of cos x graph. Actually, so let's go back to the notes and let's draw it out first. So I'm going to draw the graph of arcsine x. Right. So that's the graph of y equals arcsine x. It's like this. So from here, oops, to here. Actually, let me just do it properly, like this. Okay. What about the x and y axis? Now, because remember, inverse means we're reflecting in the line of y equals x. That means the y value becomes the x value. So originally, on the y-axis of the sine x graph, if you look at my sine x graph, you've got 1 and -1, right? So therefore, in the arcsine x graph, the 1 and -1 becomes your x-axis, 1 and -1. And this one becomes pi over 2 and negative pi over 2. Okay, so the domain of the arcsine x graph, the domain is between -1 to 1. And for the range, that's between minus pi over 2 next to pi over 2. Okay, so that's an arcsine x graph. How do you remember this? Well, there's no way. You just have to remember it. Okay, just have to remember it. So arcsine x graph. You don't often see it in normal maths. In further maths, you see it quite, maybe not very often, but you might be asked. But in normal maths, you don't often see it. But you just have to sort of have an idea what it looks like. I just realized I'm not showing the graph, sorry. So I'm just going to go through again very quickly. So y equals arcsine x graph. Sorry, this is what it looks like. The x-axis is 1 and -1 because I just explained. So that's 1 and -1, and the graph is pi over 2 to minus pi over 2. Domain is -1 to 1, and range is minus pi over 2 to pi over 2. All right. Sorry about that. I forgot to switch the sharing screen. So this is it. Okay. So pause the video and copy it down. Next, moving on. So with the sine x graph, let's look at cos x graph. Okay, cos x graph, again, you start from 1 to -1 like this. So our cos x graph will get limit into here. So it's a bit weird, but this is how we draw it. So we only take this part of the graph and we reflect it along of y equals x. So what does it look like? Well, so y equals arc cos x graph. So y equals arc cos x graph. We go from -1 again. The y-axis was -1 to 1, so therefore it becomes the x-axis on the arc cos x graph, and then we start from here to here. So that's pi over 2, and that's 0. Okay, so the domain is again between 1 and -1. The range is between 0 to pi, right? Last but not least, the y equals arc 10x graph. So y equals arc 10x graph. So 10x like this, arc 10x like this, because we're reflecting the whole thing by y equals x. Now for the, okay, so what does it look like? Well, it looks like a 10x graph, but only one of them, but it's like lying down. So how do we draw it? Well, good question. Even though you didn't ask. So y equals arc 10x graph. So there's an asymptote in here. and there's an asymptote in here. The asymptote is pi over 2, oh, that's y, that's x, that's negative pi over 2. So it's like this. Okay, right, that's it. Domain, the domain is x belongs to all real numbers, because you can see in terms of x is spanning all the way from the very left to the very right. For the range, we are limited between minus pi over 2 and pi over 2, but we cannot include the pi over 2 minus pi over 2 because they are asymptotes. So we're going to say minus pi over 2, so not including means no equal in inequality, f of x, and less than pi over 2. And these are graphs. Well, as I said, you have to recognize them, but you don't really have to, you won't be using it a lot, okay? But you have to recognize them. You have to remember how to draw it out. Right, next example, we're going to learn how to use a calculator to do that. Well, work in radians. So question A, work in radians, make sure to put your calculator in radian mode. Question A, arc sine of negative root 2 over 2. Essentially, in a calculator, you're going to just do this. But now, there's not class diagram. I just want you to put in a calculator, work it out. Okay, you should get minus pi, negative pi over 4. Just put in calculator. Whatever the calculator tells you, just write out. Okay, arc cos of minus 1. That's 1. Equal pi. You want to try last one, part C? Okay, pause the video and have a go at the question. Put in a calculator, and hopefully you will get arc 10 of root 3. Oh, I just rewrite it. Sorry, it's inverse 10 of root 3. That's pi over 3. All right, pi over 3. Okay, simple. Next one. Let's have a look. Example. One more. Given that x satisfies arc sine x equals k, am I showing the right screen now? Yes, I am. Given that x satisfies arc sine x equals k, where k is between 0 and pi over 2, state the range of possible values of x. So what you can do here is, now, part A, now, since arc sine x equals k. Now, if you don't like the arc sine x, I understand why, because you're not familiar to it. You can rewrite this. If I want to remove arc sine, I can sine on both sides. That means I can change the sign to the other side. So that means x equals sine k. Are you happy with that? Sin, S-I-N. It's not English. S-I-N. Okay, sine k. So, right. What can we do in here is to find a range of possible values of x. Well, x equals sine k, what can we do? We can draw a graph of sine k. The graph of sine k looks like this. So that's the x-axis, the horizontal axis becomes k, and the vertical axis becomes x. K is bound between 0 and pi over 2. So in this part of the graph, you can see x values only going from 0 to 1. So therefore, part A, the possible values of x is between 0 and 1. Oh, actually, we can't include 1 because k, actually, we can't include 0 either because k between 0 and pi over 2, there's no equal sign in the k value, so we cannot equal them. So x is between 0 and 1, right? Part B, express in terms of x cos k. So part BI, we're going to use identities. So we use identities. Okay. So we know, okay, x equals sine k. So that's the definition in here, what we know. Now, because sine square k plus cos square k equals 1, therefore, now x equals sine k. So sine square k becomes x squared plus cos square k equals 1. And then, so this is what I've done. Next, I want to make cos squared k a subject. So cos squared k equals 1 minus x squared. So cos k equal plus and minus square root of 1 minus x squared. Now, but since k is between 0 and pi over 2, between 0 and pi over 2, that's the first quadrant. So first quadrant. So imagine, if you remember the class diagram CST, we're here, right? We're here. So first quadrant. Therefore, okay, therefore, cos is positive. So therefore, actually, I should write it in black. That's the proper answer. Therefore, cos k equals positive 1 minus x squared. So we ignore the negative, essentially. If part BI. So when you square root, there's a plus and minus. So we can still justify why is it positive, not negative. Part B2, let's do that. So 10k, tank. Oh, we got cosk, we got sink, and we got tank. Anyway, 10k, 10 equals to sine k over cos k. And what do we do about sine k? Sine k is x. Cos k from the previous answer is square root. Oops. Cos k equals x over 1 square root 1 minus x squared. Yeah, and why is it all positive? Because k is between in the first quadrant. So that's fine. All right. Part C. Given instead that k is between negative pi over 2 to 0, how, if at all, are your answers to part B affected? Well, if k is between minus pi over 2 and 0, maybe think about what I just explained in here. Which quadrant is k in now? Which quadrant is k in now? So if k is between 0 and minus pi over 2, that means going backwards. That means we are in a cos quadrant, in the fourth quadrant. In the fourth quadrant, only cos is positive. So therefore, cos will stay positive, but 10 will become negative. That's the answer. Okay, so part B2, part C. Okay, if k is, if k is between 0 and minus pi over 2, that means that's the fourth quadrant. So you can draw a little class diagram for yourself. That means we're here. So therefore, cos k remains positive. So unchanged. So unchanged. So cos k is still square root 1 minus x squared. But 10k becomes negative. Therefore, 10k now equals to negative x over square root of 1 minus x squared. And that's the answer.
And here comes the last exam practice. You can pause and have a go with the question, but if you're unsure of the arc cos and arc sine, I will still go for it as an example. It's quite a different question, so if you want to listen, feel free. Right, given that y equals arc cos of x, sometimes you put a double C, sometimes just one C. It's just, I think it's a tomato situation here. Or potato. Minus 1, x is between minus 1 and 1, and y is between 0 and pi. These are not important. Part A, express arc sine x in terms of y. So first of all, you need to think about, okay, how do we change arc cos x to arc sine? Well, quite difficult, because we know how to change cos and sine, but we don't know how to change arc cos into arc sine. So think about this. What we want to do is, why don't we make a cos to the left-hand side? So question A, why don't we make y as cos? So first, actually, let me rewrite the question. So y equals arc cos of x, and then bring cos to the left-hand side. So cos y equals x, cos y. Now, here, that's a trick. How do we change the cos into sine? So what is the relationship between cos and sine? Now, if you remember your special values that you've learned GCSE about sine and cos, 30 degree, 45 degree, and 60 degree, what you've learned is sine 30 is a half, sine 45 root 2 over 2, sine 60 is root 3 over 2, and root 3 over 2, root 2 over 2, and a half. Have you ever wondered why these two values diagonally are the same, and the other values, root 3 over 2 is same as the other one, diagonal, and root 2 over 2 is the same as root 2 over 2. The reason being is, with sine and cos angle, as long as the angles add up to 90 degree, they are freely interchangeable. So for example, if I have sine 10 degree, I can rewrite as cos. As long as two angles add up to 90, that means this one will be 80 degree. Then they are the same. If you don't believe me, you can try putting a calculator. Make sure you put your calculator in degrees, not in radians, because if you put in radians and then you come and blame me, that's wrong, and that's your fault, that's not mine. Next, or if I give you another one, maybe sine 75 degree, that will be the same as cos 15 degree. Or cos 20 degree, maybe you can fill in the blanks, what will be that equal to sine? So add up to 90, 70 degree. Now, if you use that logic in radians, y, if I do cos y, for example, cos 80 degree, if I want to change in sine, I can do sine 90 minus that. But because this question radians, so we can have to rewrite as sine pi over 2 minus y. All right, and equals x. Now, this step is the most important step in here, and I've explained it. Okay, so I think for 2 marks, the 1 mark is given definitely for this step. Next, I want an arc sine, so I can move this sine to the right-hand side. So pi over 2 minus y equals arcsine of x. Or if you don't like arcsine x for now, you can rewrite as just, step by step, inverse sine of x. And then pi over 2 minus y equals arcsine of x, which is the answer. Part B, hence evaluate arc cos x plus arcsine x. Well, what we know is, let me write down the question, arcsine x, or arc cos x, sorry. Order matters. Okay, arc cos x is that when you have burger, you must have the burger before the chips. The order matters. Arc cos, we know from the question, is y. So that's y. All right, and arc sine is, from part B, is pi over 2 minus y. So plus pi over 2 minus y. And let me just underline it for you. And therefore, if you simplify it, y plus pi over 2 minus y, that's the same as just pi over 2. And that's the answer.